A very good afternoon to all of you. Okay, today we are going to learn the ordinary differential equations. Okay, for the introductions, given y equal to exponent 0.1 x squared. Okay, as you have learned in calculus subject, given a function y of fx, you can easily find its derivative dy dx. You differentiate y respect to x, you get dy dx equal to gets the dy dx, which is 2 times 0.1 0.2 x, then exponent 0.1 x squared. This is what you learn in calculus. Okay, in ordinary differential equations, cause or ordinary differential equation or short form, we call it as ODE. It is given an equation. When given, for example, this one, this is what we call O. This is what we call ODE. ODE. It's actually equation. It consists of the derivative. If here only dy dx, so this is what we call first order ODE. It consists of derivative, and we have a second derivative d2y dx2 and the function of x. So this is what we call ODE. So the past here, given an ODE, we would like to get back the y. We would like to get back the y. So how to get it back? Because ODE can describe a lot of phenomena in the real life of physical system. Okay. Example here is actually from the equation y equal to exponent 0.1 x squared. You will find its derivative. You get dy dx equal to 0.2 x exponent 0.1 x squared. So given an ODE, how to get it back? How to find back the original y? Of course, from here you know the solution y is equal to exponent 0.1 x squared. Okay, but if you don't know, just only given one ODE here, how do you find the y here? Okay, and in this case, you can actually from here you can bring the dx to right hand side. So you got dy equal to 0.2 x exponent 0.1 x squared dx, and then later on you can integrate both hand side. Integrate dy, you will get y. To integrate the right hand side here by using substitution techniques, where you replace the 0.1 x squared equal to u, then you have got the du is 0.2 x dx. So here 0.2 x dx you replace by du. So exponent 0.1 x squared is actually the u. This is u. So you got integral exponent u du. You get back exponent u. Replace back the u is actually 0.1 x squared. Okay, because when we do integration, we plus c. So for solution of ODE, you just plus c at right hand side enough. So you got y equal to 0.1 x squared plus c. C can be any value depend on the initial condition. Because here, initially you know here, if I put plus c here, plus c, because you differentiate c, you got 0. That's why you get dy dx equal to 0.2 x exponent 0.1 x squared. So this is introduction of what is ODE, and then now let's look at some definition of the ODE. So this one is already said ODE, ordinary differential equation. Actually, we have two types of differential equation. We got ordinary or partial derivative. Ordinary differential equation (ODE) or we have partial differential equation. Got PDE. PDE. Here ODE we have only ordinary derivative. PDE, normally the equation, you can see the symbol del. Okay, the division, we have y equal to fx. Okay, y equal to fx. And then so where the y is dependent variable, x is independent variable. So this is ODE because we got only ordinary derivative. Means if we have function of one variable, if we find its derivative, we form it into an equation. The equation is actually ODE. Because here we have here where the x is actually the x is a dependent variable, t is independent variable. So you got dx dt. This is d2x dt2. So this is what we call second order ODE, second order, because the highest derivative is second derivative. So this is the second order ODE. Okay, x dependent, t is independent variable. Yeah, this is what we call the partial derivative, normally the symbol del. Partial derivatives actually come from function of more than one variable. U dependent on x and y. So from u, you can differentiate respect to x, you can also differentiate respect to y. So if you have function more than one variable, okay, function of more than one variable, then we find its derivative is what we call partial derivative. If an equation consists of the partial derivative, this is called partial differential equations, or we call it PDE. Okay, so we look at some of the example. What is ODE? What is PDE? Okay. So we got we have dy dx plus 5y equal to exponent x. We have only y is a dependent variable, depend on only one variable x. So this is ODE. Or you look at the symbol, you got d is ODE. Okay, so this is first order ODE. Also y only depend on x. So this is up to second derivative. So this is second order ODE. Okay, here you notice dx dt, dy dt. Oh, this one is they add up two. X depend on t, y depend on t. Only they add up two ODE. So still ODE. The third also ODE. Okay, sometimes you put dy dx or you put y prime. Okay, this is y double prime is actually d2y dx2. Okay, this is a second order ODE, but the order here, power here you got 2, this power 3. Still second order ODE, but it's not it's a non-linear ODE. Okay, this is x y prime plus y equal to 3. This ODE, this ODE. Okay, PDE normally you will see the symbol del. Like this one. Del to u, del x will mean u depend on x and t. U is a function of. We put it. U actually is a function of x and t. Okay, so given u is a function of x and t, you can find partial derivative of u respect to x. So you got me del u del x. So up to second derivative, this del to u del x2. So you can find del u del t. So an equation consists of partial derivative. This is called PDE. This one, suppose they use symbol del because z also similar to here. Z is a function of x and y. That's why you can find del z del x means del 2z del x2. This del z del y del 2z del y2. This is also del. So this is PDE. Okay, but this one you see, x depend on only one independent variable t, y depend on one independent variable t. So you see the different variable is on top, but here z depend on x, z depend on y. So this is PDE, but this is ODE. Okay, here u depend on x and y. So this is also PDE. And then classification of ODE can be classified by order, degree, linear or non-linear. Okay, order of an ODE is the highest order derivative appearing. Means if you have a d2y dx2, that will be second order. Degree of ODE is degree of the highest derivative. Degree of highest derivative. Okay. This is second order. This first order. Okay, degree. This is degree 2. Because degree of highest derivative here is 2. And then the power here 2. So this is degree 2. Not look at here. Even though 3 is greater than 2. But the definition said is degree of ODE is degree of the highest derivative. It's not the highest power. It's degree of the highest derivative, or power of the highest derivative. Okay, example. This one second order, degree 2 in here. Okay, this is first order. Degree 1. Degree is a power at the highest derivative. Okay, linear or non-linear? Okay, a linear is normally the degree is 1. Then you have here, this is up to n order. You see power 1, okay, or power 1. Otherwise, it will be non-linear. Okay, for example, here, y minus x bracket dx plus 4x dy equal to 0. You may do y dx divide by, okay, if we divide by dx, okay, 4x dy dx plus 1. If we divide by dx, this one divide by dx, 0 divided by dx is 0. So this one 1. So you have 4x dy dx, okay, plus y minus x, bring to the other side, this is equal to positive x. Okay, to classify whether linear or linear, we look at the power for the derivative. Here, dy dx power 1. And then y here must be power 1. Because the definition here, up to equal to gx. The right hand side is a function of x. And here can be a naught x y power 1. Okay, if we have a naught x, it can be a function of x or constant. Like this case, so plus 1 y power 1. Y power 1. Right hand side is function of x. So this is a linear ODE. Okay, this one. Right hand side 0 also can. Y power 1, y prime power 1, y double prime power 1. So this is a second order linear ODE. Okay, the third one, also third derivative here, power 1, dy dx power 1, the coefficient can be function of x or can be constant, y power 1, so this can be linear or can be function of x or constant value. So all satisfied means for linear all the derivative, okay, must be power 1, and then okay, this is 1, right hand side is function of x, coefficient for your y derivative can be a function of x or the constant value. So this satisfied, so this is a linear ODE. Okay, this one is non-linear because coefficients here, coefficient for y prime is not function of x but function of y. That's why, because this is not function of x, that's why this is non-linear. Okay, and E also non-linear because here you cannot have function of y, but you can plus function of x multiplied y power 1. So okay, so this one non-linear because of here the sin y. If plus y, then this is linear. Okay, this is non-linear because here y squared can be only y power 1. G linear because dy dx power 1 y power 1. Okay, the h non-linear because you have here this one power 2. Beside this is function of y, cannot. So this non-linear. Okay, this one power 1, okay, linear. Function of x can, dy dx power 1 can, y power 1 can, ln x can. So this is linear. J, okay, d2y dx2 power 1, the function of x, this function of x is power 1, this y power 1, this cos x, so this is linear. K, this is non-linear because you have here power 3 over 2. This one power 3 over 2. This is non-linear. Okay, I think we're just up to this one for your part. So we have introduced what is ODE. Basically, an equation consists of derivative, the normal derivative, and we would like to find back the dependent variable y here. So differential equation got two types, PDE and ODE. ODE consists of the ordinary derivative. PDE consists of partial derivative. So you can see in the simple del here. Del here is actually your dependent variable. For example, in this case, u dependent on x and y. So you can differentiate u respect to x, u respect to y. So this will give an PDE. If ODE, you have only function of one variable, y depends on x. You can find dy dx, d2y dx2, and so on. And then ODE can be classified according to the order. Means is depend on the highest ordered derivative. Degree is degree of the highest derivative. Okay, example. Okay, this is the highest derivative is second, so the second ODE. Okay, degree is actually dependent on the power of the highest derivative. So this is 2, so this is degree 2. Linear or non-linear, actually here. Right hand side must be function of x. Then you may have y power 1. Coefficient of y can be function of x or constant. Can have a, okay, if you only up to first order, then you have dy dx power 1. Coefficient of dy dx can be a function of x or constant value. If up to second order, okay, ODE, d2y dx2 must be power 1, and the coefficient can be function of x or constant. This is up to n or the ODE. So d n y dx n, also power 1 coefficient, can be function of x only. So this, if satisfy this format, then this is a linear ODE, otherwise it is non-linear. Okay, with this case, we stop here for the introduction to ODE, classification of order, degree, linear and non-linear. With this, thank you for your attention.